So hello everyone and welcome back to another quick video that, this is just the smartphone. I do not have the audio set up right now. The light is also coming from the camera and the battery is running low, so I'm gonna have to make this quick. So what you see right before you is one of the DC to DC Buck converters that I've ordered. For the ePower modules that I was planning to make. So that's the 470 and then the other 580 that is like completely dead. I'm going to turn it into an ePower and I'm going to need these little things for that. Originally, like, I ordered 10 of these smaller ones, but then when they arrived today, it turned out that 4 of the 10 ones were these bigger versions that technically they are the same. They have the same inductor, potentiometer, they have the same, it says here on the back, LM2596, that's this part right here. And like, yeah, so functionally they are identical. It's just that these bigger ones, they have a voltage display, and they have a button right here so you can switch between input and output voltage. And they have these clamp terminals where you can put in wires without soldering them, which is rather nice. And what I thought I'm gonna do here real quick is just demonstrate how they work and that they work. I'm using one of the bigger ones so we can see the voltage, and I don't have to use my multimeter for it. And what I'm gonna do here is this right here is a delta fan. It's 12 volts, 1.6 amps. These are rated for 3 amps, so they can handle the fan. And like I've made a very short video a while ago where I used the Molex connector that I soldered on here and like plugged it right into a power supply and then had this going full blast. And what I'm going to do now is, like, as you can see, the output is connected to this DC to DC Buck Converter right here. And yeah, what I'm going to demonstrate is that you can control the speed of the fan by changing the voltage. So if I turn the power supply, that's like, this is where the power is coming from. If I turn the power supply on, you can see that the fan is turning. And so yeah, this is output, this is our input, so we're getting 12 volts from the power supply, and output is 4.5 volts right now, which is the minimum voltage for this fan. So if I turn the potentiometer, if I turn it down, the fan turns off. And if I turn it back on again, like turn it back up to like 4.4, it does not turn. 4.5. That's 4.5, 4.6-ish, that's where it turns on. And now if I go all the way up, because we since our input is 12 volts, we can go like, this is just essentially a small single-phase VRM, even though like this is our inductor and our entire VRM is in this little chip right here. So it's more of like an adjustable low dropout regulator with that. Like, literally how this works is it just has this potentiometer attached to the feedback line. And how this works is literally the same way that the feedback mod on like a volt mod would work. So if I turn the voltage, oops, that's down. Turn the voltage up. It's kind of not good to see, right? I should see the voltage of 5 volts right now. And suddenly it's really loud. So we can actually not go up to 12 volts completely. It actually stops at 10.8 volts because this fan is drawing so much power that the voltage drops because of it. So this is our maximum, and you can see it has enough lift to like lift the mouse pad. So I'm gonna turn it back down because it's really loud. So yeah, here it is. Here we are at around 5 volts, and it's manageable again. It still does like, it does shuffle a lot of air still, because, well, it's a really powerful, really thick fan. And yeah, so with these little converters right here, or the smaller version that I actually wanted, and then I got 4 of these, which are really nice. Yeah, so what I'm going to do with these is exactly what I just showed you. I'm going to have adjustable voltage. So you can see here I put a 5 on this, and on the back also 5 volts. This is set to 5 volts, and this I had set to 3.3 volts originally. Now I have set it higher because, of course, the fan won't turn with less than 4.5 volts. And these are used for the ePower modules that I'm going to make to supply 5 and 3.3 volts. Because once you cut a graphics card, you, depending on where the VRM is, on high-end card it is usually on the right side where the PCI Express connectors are. And those connectors only supply 12 volts. So you're going to need a 5 and 3.3 volt power supply, because most of the time your PWM controller, sometimes your driver chips, sometimes even your MOSFETs will require 3.3 and 5 volts. Because 3.3 volts usually comes from the PCI Express slot, which we have cut off. And then for 5 volts, most graphics cards have a low dropout regulator on them that converts 12 volts down to 5. And most of the time that is on the left side, which is the side that we're calling off. Sometimes you get to keep that 5 volt LDO, which is the case with the 470, for example. But you have to rewire it, because usually it takes its 12 volts from the PCI Express slot as well, and not from the connectors that we have left. And yeah, so if I get the 470 power board working, which I've kind of run into some issues with that one, but the 580 power board, I've monitored like what voltages the chips need to work and all that stuff. That one should work, and I'm going to use these to give that power board 3.3 and 5 volts. And you could use these for basically every time when you have a higher voltage and you need it regulated down to a lower voltage, and you don't need a lot of current draw, which, well, these are 3 amps. You're not going to power a graphics card, like a graphics chip with this, or memory. Those pull a lot more than 3 amps. And also because this is a single phase, I think I've read in a datasheet that this IC right here has a switching frequency of 150 kilohertz, which is really, really low. Like, usually graphics card VRMs have double that with 300 kilohertz. Sometimes you get 500, 600. Most of the time the converters, the controllers and the MOSFETs are actually capable of 1 megahertz, but that's so high, basically no one's running it, except maybe an extreme overclocking card. And yeah, so this IC right here, which is the LM2596S, you can find a datasheet for this. It is made by Texas Instruments, if I remember correctly. And this is rated for 33 volts, 36, something in that range. It's what it supports at max, and you can also see the capacitors on here. This one's rated for 50 volts. This is for 35 volts. The other module has 2 35 volt caps, and yeah. So like, if I can get that more onto the camera, this is the other module. You can see I also have a tiny LED that shows which, if you have input or output selected. This one also has a tiny LED over here that just shows that it's running. And yeah, like, basically these are the same. The difference is these have these clamp terminals and the voltage display with the switch. Apart from that, you have 2 capacitors, you have the IC, you have your inductor, you have your potentiometer, and that's basically it. It's a really, really small, simple board, because basically your entire VRM, except for the inductor, is integrated into this LM2596S chip. And yeah, so basically whenever you need a voltage, like you have some amount of voltage and you need less of that, you can use one of these, as long as you don't exceed 3 amps of power current draw, which, well, if you have an electronics project, is probably not going to be exceeded, because you've seen how powerful this fan is. This is only 1.6 amps, so you can get plenty with 3 amps. And yeah, I really don't want to drag out the video too far. Also because my battery is, I'm at still 25%, okay, so battery is actually going okay, but we are at, coming up at, well, the camera says 10 minutes, 37 seconds, but there's always a part that I cut off in the beginning. So yeah, I really don't, yeah, I guess I have I've said everything that I wanted to say. Maybe, if you want to get some of these, just put into eBay this name right here, the LM2596, or like this LM2596 DC-DC, and you will find plenty of these on eBay, I guess AliExpress too, like your usual parts shop. And I ordered a pack of 10 of these. Well, again, I was oops, Linus drop tips. I was expecting to get 10 of these, but actually I got 6 of these and then 4 of these bigger ones, which, well, I really like these because of the voltage display and also because they're easier to hook up. Which, these, I don't really care about the voltage display and the hookup points for these when I permanently attach them to graphics card e-power modules, but like, if you have an electronics project, like you wanna build a desk fan, like put a fan like this on your desk and then have speed regulation for it, this would be really useful. So yeah, you can find these on eBay by just putting in the LM2596 and then maybe DC to DC if you want to specify. And so a pack of 10 of these cost me like 10 euros. Less actually, I think it was only 8 euros. And then also free shipping. These do come from China and they took about 2 weeks to arrive. But I think you can also find them locally for slightly more. And yeah, these are really, really nice things. And these are basically, there is something that is basically this, which is the Elmore Labs Ample, which is, well, Elmore Labs is associated, like, Elmore is the, like, he is Asus, like the Kingpin from Asus, which Kingpin works with EVGA, or like High Cookie works for Gigabyte. They're like the extreme overclockers associated with that brand. And Elmore sells these ampoules, he calls them. And these are basically exactly this, only that his one is a slightly more complex version. It's not like an all-in-one chip, it's like still a single-phase VRM, but like with dedicated components, and it has a heatsink on it, and it's rated for 20 amps, not 3. So you can use that ampoule to power like a memory system. Not a GPU core, but like a memory GPU memory system would be able, you'd be able to power it with that. With this one, 3 amps, maybe on a low-end card, but like not on a big 384-bit card like say a GTX 580 or 780 Ti, or, well, a 2080 Ti technically is not 384-bit because one module is missing, but I'm just rambling at this point. So yeah, this is a quick demonstration of how these little tiny DC to DC buck converters work. I really like them. And they're really, really cheap to get. Like, if you want to do electronics project, you can get some of these and like have some fun. And yeah, I turn the power supply off. And yeah, okay, that's it with the video. I'm running out of things to say. So thank you all for watching. Hope you enjoyed, even though it's like the audio is not set up because this is a very quick video just. But yeah, thank you all for watching, and until we see each other next time. Goodbye.